Hello, so today we're going to be looking at impulse and momentum. And to do that, I have this little Chinese checker piece that I'm going to be dropping from 2 feet above this table, and we're going to see how high it bounces. And using those two measurements, we're going to see if we can find the coefficient of restitution.
Okay, so let's go over this momentum slash impulse of this Chinese checker piece. So here's our initial sketch. It's pretty simple. We are dropping our ball from about 2 feet up above this tabletop here, and we are dropping from rest, so there is no initial velocity. And then looking at the slow-mo, we see that it bounces back up to a height of about 1.5 feet. And from this, we want to find the coefficient of restitution, E. So some givens and assumptions. We were given that we are dropping rest, so V naught equals 0 feet per second. Our initial height is 2 feet, and then our rebounded height is 1.5 feet. And some assumptions we have to make is that there are no drag in this scenario. We gotta treat our piece, our ball, as a particle, and then we are assuming that the table does not move during the collision with our Chinese checker piece, and gravity is negative 32.2 feet per second squared. So here is a sketch outlining kind of all of the phases we kind of want to look at. So we establish our coordinate axes here in the top left corner where y is up and x is in the horizontal direction. And we see our first scenario all the way to the left is v naught equals 0 at 2 feet. And then we want to find the velocity of our ball right before it hits the ground, right before it hits the tabletop, and then the velocity right after it bounces off the tabletop, v2, and then we know that at its rebounded height, there is no more velocity in the y direction or in any direction since we start with 0 velocity. So we know that v3 equals 0 at 1.5 feet. And then some free body and inertia diagrams is free body, we have the weight of the ball pulling it down. Inertia diagram is the acceleration in y going down. So here is our analysis. We do need to bring back some kinematic equations for this. So we bring back the equation v squared equals v naught squared plus 2 times acceleration times distance. So on the left, we're looking for v1. So v1 squared equals 2 times negative 32.2 times negative 2. The v naught squared is 0 because we are dropping from rest. And then the distance is negative 2 because since we established a coordinate of y is up, we know that d, the displacement, is negative 2. And solving that out, we get v1 is 11.35 feet per second, but we put a negative sign for sign convention because we know at v1 our ball is going down. And then moving over to the right, we replicate the same formula where we have v3 squared equals v2 squared plus 2ad. This time v3 goes to 0 because v3 is a scenario where the ball is no longer is temporarily not moving, 0 velocity. And then we're solving for v2. So this equals v2 squared plus 2 times the acceleration, negative 32.2, and the distance 1.5. And then solving that out, we get v2 is 9.83 feet per second, and we are positive because at this time we are going up. And then we bring out our formula for coefficient of restitution, which is VB2 minus VA2 divided by the quantity of VA1 minus VB1. And it doesn't really matter which one we set as A or B. One of them is going to be the table, one of them is going to be our Chinese checker piece. But we know that if we set the table as VB, VB2 and VB1 will both go to 0 because our tabletop is not moving before or after the collision. So then we know that VA2 would equal our V2, and our VA1 would equal our negative 11.35. So putting that in, we get E equals negative 9.83 divided by negative 11.35. And putting that into our calculator, we get E is equal to 0.866.